Hi everyone, welcome along. Des here again, and this will be lecture 13 in the AlphaChem side of our Advanced Manufacturing Technology module. And today we're going to talk about two things, nesting and pocketing. Hopefully we'll get onto that as well. So, we'll start with nesting, and it'll be a bit more clear in a minute when we actually do an example of it, but nesting allows you to take a number of different components and place them very carefully on a sheet, say a large 8x4 sheet, so as to minimize waste and make sure you get as much as possible from the sheet. So to help explain this, I've moved over to AlphaChem, and what I have here is the stool that we've been drawing now for a few weeks. You can see there are three parts of it. There's the leg, the lock key, and the top. And if you haven't these drawn, refer to an earlier video where we draw the geometry and apply the tooling. And you'll remember from those earlier videos, I wasn't too worried about where I actually positioned them. Now obviously, this is not very efficient. It would make a lot more sense for me to take that circular top and position it in the void of the leg there. And also you'll notice I didn't draw four legs, nor did I draw two lock keys. I just drew one of each component. What we can do now, after we've drawn the geometry and set up the tooling, is to set up a sheet, let's say an 8x4 sheet, and nest these very carefully onto the sheet to minimize waste. So to help me there, I'm going to go to View and XY to make sure I'm looking at a plan view. And I want to draw that standard sheet, but I want to start it at 0, 0, which is about here. So let's just move these first of all. So I'll go to Edit, I'm going to go to Move, select Everything, and select Finish. And when prompted, do I want to move the geometries or the toolpaths or both? Well, I want to move both in this case. Just going to pick them up anywhere for now and just move them over to the left out of the way. That means now I can take a rectangle starting at 0, tab 0, enter, and moving all the way up to 2, 4, 4, 0, tab 1, 2, 2, 0, enter. I'm pretty sure that's the size of a typical 8x4 sheet. So just take note of the order I've done things in. I've drawn the geometry and then applied the tooling. If you don't apply the tooling first, it means you're going to have to apply the tooling to all individual components afterwards. So finish all the work on the components first of all, then we'll nest them into the sheet. So to do that, we're going to go up here to the nesting tab, and there's a lot of different ways of doing this, and I'm going to show you the most basic, I suppose simplistic way for now, and as the module progresses I'm going to show you some more advanced tools. For instance, you can have this, define sheets and small part zones. Now if you have a particular area of your CNC bed that maybe the suction is poor on or it's damaged, you may not want to rely on the suction to hold this small piece. So when it automatically places the leg, the top, the lock key on the sheet in a few minutes, you could potentially have a weakness in your bed CNC, so you can define that as a no-go area for small parts. Also, you could save a cutoff if the most efficient use of your sheets is to have maybe this strip or a certain shape that you want to cut off every sheet and not nest into. You could also do that. So like there's a lot more to nesting than we're about to do now, but we'll get to that as I said. So to begin with, we're going to go to Nest Parts. And true shape nesting, rectangular nesting, and manual nesting. We're not going to do manual nesting because we still in that case would have to pick up the components and drag them into place. Rectangular nesting means that the likes of this leg would have almost like an invisible rectangle placed around it, and it would not allow this top or this lock key to actually be cut from the void in there. So I don't want that. I want true shape nesting. I don't mind if one component kind of goes into the void of another component, because that'll give me the most use out of a sheet. So true shape nesting for now. Maybe a more advanced way to do this, or efficient way, would be to use a thing called a nest list. If we were to make this tool over and over again, we draw it once and save those three components in a nest list, maybe call it stool, and then call up that every time we need it. But for now, we're going to select parts from screen. And I want to nest not just toolpaths, not just geometries, but both. So toolpaths and enclosed geometries. So press OK. Now down at the bottom you're prompted, select shape to nest. Well, I'm going to use a window, so I'm going to carefully draw a window around the leg. Now I say carefully because if you miss it ever so slightly, you may leave behind a toolpath or a piece of geometry. So make sure you get the box fully enclosing the leg in this case. The name of this part is going to be leg. How many do I want? Now if you tick maximum possible, it may very well just fill the sheet with only legs. It mightn't put any tops or lock keys into it. So I'm going to make 2 stools, and in 2 stools I'm going to need 8 legs. Rotations to try. In some cases the grain direction will be very important. Now if this was being cut out of MDF or something, it wouldn't matter at all. So you could go any angle. But if you want, say, the wood grain to go the correct direction, you more than likely only want to allow it to rotate 180 degrees at a time, or 90 degrees. So the way you draw it is the way it's going to try to machine it. But you can set here what liberties the computer can take when trying to nest it onto the sheet. I do want the grain direction going up and down, so let's just go 180. It means it'll either put it that way or rotate it through 180 degrees. Try merge shape. I don't really mind whether this is a mirrored version, because sometimes things have a handedness and it will not mirror or won't work if you mirror the component. In this case it doesn't matter, so I will allow the computer to try to make mirror images of it. Define as a small part. It's irrelevant in this case, but if I wanted to define the small part zone, where is it? It's up here. If I had previously defined the small part zone on the sheet that no small parts were allowed to be machined from, now I could tick that. Now kit number, if you're putting this together as a flat pack, you could actually label them. You could label this as part number 1, part number 2. Priority, the highest, if I set this to be priority 1, it would try to get all the legs first. If the top then was priority 2, it would then try to fit in as many stool tops as possible, and so on. I'm just going to leave that at 1 for now. Press OK. So you then have to do the exact same thing for, let's say, the top. I'm just going to call that top. I don't need 8 tops, I need 2 tops for 2 stools. In this case I'm going to be spraying this top anyway, so I'm going to allow any angle. I will try a merge shape and press OK. Let's finally, now you notice by the way they are disappearing as they're selected. So now I'm going to select the lock key, call it lock key. I need 4 of those. No, sorry, I just need 2 of those. Or no, sorry, I need 4 of them. Alright, yeah, so 2 per stool. Any angle, let's just go 90 degrees this time. I will allow the merge shape and press OK. And you can see down here it's trying its best to keep prompting you and keep allowing you to put in more pieces on the nest list. Here is our nest list. You can see I've got the leg, the top and the lock key. Whenever you're finished selecting components or parts, what you do is you tap escape. If you look down here, it always prompts you for what the computer needs next. It says escape equals no more shapes. I have no more shapes, so I'm going to hit escape. Now they come back, but it says select sheet to nest into. So I'm going to select the edge of this sheet. How many of these sheets? You can just leave 0. That means there's no limit to the number you have. The sheet thickness is 18. You can set the material. I'll leave it to be MDF for now and press OK. Now it's looking for the next sheet. You could have another sheet drawn up here or over there to the right hand side. So when you're happy, you just go escape, no more sheets. So just tap escape. And this is the last series of options we have. The 2 stools will not fill this sheet, but to make most efficient use of the sheet, we want to pack them to the left or the right. We don't want to just fill up the whole sheet with 2 stools. So what I want to do is pack to the top left. That's fine. The minimum gap between parts is something small, so I'm just going to leave maybe 5 mil. Sometimes you might have a damaged sheet, or you may very well want a nice square edge at the sheet, so you're not going to rely on the fact that the sheet is perfectly crisp and square at the edge, so you might allow a gap at the edge of the sheet of 5 mil. Time per sheet, so extra gap at lead in start. If you have a lead in or lead out, you mightn't necessarily want the components to be wedged together too tight, because the lead in for one component might clash with the other. So I'm just going to leave that be for now. Time per sheet, that means how many seconds is the computer going to dedicate to calculating the best fit per sheet. Now there's almost an infinite number of locations and rotations and variations that these components can fit in that sheet. So what you typically do here is limit it to 2 or 3 seconds. Now the more small parts you have and the more complexity you have, you may want to consider upping that to 4 or 5 seconds, but that's going to cost time. I'm going to leave it at 2 seconds for now. There's a lot of other options over here that you can actually work through and tick on if you want. The only one I always tend to tick on is this, use name identifiers. That means that if you've got a lot of components you may not know what they're called. So over here they're called leg, top and lock key. I just like ticking that because as you'll see in a second it will label them. So if you press OK, it's going to start working away, and here we have it. Those yellow letters are the labels I was talking about a moment ago, and what it's done there is it's efficiently packed together two stools for us. It's got all the components for two stools, and it's packed them as best as it can over to the left. Now I know what you're thinking, it might have been more efficient to put another little lock key in there or a lock key in there, but we didn't ask it for more than 4 lock keys. It's given us the 4 lock keys. Had I asked it for another 2 or 3 lock keys, I assure you it would have put maybe 1 in there and maybe 2 in there and 2 in there. Before I run the simulation, these geometries that I've drawn over to the left, they exist. They are part of the simulation, part of the software, part of this part. So if I go to operations, I can see there's 2 different types. There's not in a sheet, which actually is those 3 components, and sheet A1. This is sheet A1. I can see that because it's got a bubble over there. If I expand sheet A1, there's all the operations that are applied to process the components on this sheet. I don't necessarily want these 3 to be machined. So I'm just going to turn off just tick the box there, and it'll turn off the operations there. If you wanted, you could delete those now, but they're not going to get in the way. Let's now go to View and ISO, and let's give this sheet a bit of thickness. So 3D Set Materials, going to click that yellow edge. Let's say the top is 0 and the bottom is -18, and press OK. And now let's just run the simulation. Now it's a little glitch in my computer. I need to go to Home first, select Post, or select the Post processor. I just need to basically set the printer or set the CNC. Sometimes this is done by default. It's just a little glitch on mine that I have to do it every time. So I want to select this printer here, this Wiki B15 Optimat. If you don't have that one, it doesn't matter. Pick one and it'll work. In fact, if you just go to Alpha Standard 3X router, I'll just pick that one for today. That should work as well. So let's now go to View, Solid Simulation, and press play, and it'll start machining away all those components for you. So here we are after the machining, simulation rather, has run fully. You can see it takes an awful lot of the work out of doing something like this. This is what I was talking about a while ago. It doesn't seem to have caused an issue here, but sometimes if you have a lead in and a lead out, if you've got the components too close together, now it didn't happen in this case, this lead in would actually clash and break the other piece. So you don't want the lead in to start over here. In this case it would damage that leg. It would start here and then move in to process the circular top. You want to make sure that there's a nice gap between lead in and lead out. So I'm going to press stop to close that simulation, and I'm going to try one other thing. So I'll go back to operations and turn back on those operations. And I'm going to go to nesting, nest parts again. This time I'll just show you what the manual nesting does. So click manual nesting. Use original nester. If you ever have trouble and the nest won't work, just try the original nester. It's just a different algorithm. It's a different, older version of the nester. Sometimes you'll find that will work where the other one won't. So I'm going to manual nesting. Select parts from screen, that's fine. And I want to nest toolpaths and enclosed geometries. So the minimum gap between paths, let's leave that at 5 mil. Gap at sheet edge, let's leave that at 5 mil. And we don't really want a gap at the lead in, so press OK. Select shape to nest. So I'm going to select that shape there. And move to new position. So you can see as I drag it around, it's going to turn that amber color in my case, but as soon as I go to somewhere that it's not happy with, it turns red like that. So that's what the manual nester is. It actually allows you to move them around like this and position them. So it's quite happily going to let me position it there, but as soon as I put it somewhere where it clashes, it actually won't allow me to clash it in on top of the geometry, but it will allow me to clash it because the tool paths overlap. So what you're looking for is position it somewhere like that. And if you want to rotate it, you simply press F2, and F2 allows you to rotate it manually like that until you get the direction you're happy with. So that is another way of nesting them, and some people are quite happy with that. You can put as many of them as you like there. For instance, now you can press F2 again, and we'll rotate it that way, and now you can link them into like that. Okay, I'm not doing a great job of that, but you get the idea. Now, in the same way that we just did an introduction to nesting, and there's a lot more to come with nesting, I now want to do an introduction to pocketing, and there's more complex pocketing exercises to come down the line. But it's very important at this point in the module that we have a good understanding of the basics of nesting and the basics of pocketing, and that we can do simple exercises with both. A pocket, in terms of CAM operations, is when you have a shape like this where we need to remove a shape or a solid or an area or a void, but it doesn't go all the way through. So if I was to just machine that loop all the way around but all the way through, the piece in the middle would fall out. That's not the case here. We actually have to machine back and forth to actually remove all the material from there to make that little shape. It's called a pocket. And there's lots of different options that you're faced with when you go to do a pocketing exercise, and we'll explore those in a few minutes. But just to get started, I'm going to show you the process plan, and we're going to draw and pocket this before we explore too many of the different variants of the options. So our process plan is, first of all, we're going to rough area the circle. We're going to cut out the circle first of all on the outside. We're going to use a flat 10mm cutter for that. Then we're going to rough out the 4 different pockets with a large cutter. As a rule of thumb, you should always try and remove as much material as possible with a large tool. When you do that, it minimises the amount of movement the tool has to make, and it's a lot more stable and a lot better and more efficient to remove a lot of the material at once. And then we'll try and get into these little corners there with the smaller tool, the flat 5mm tool in this case. Now moving over to AlphaCam again, let's give that a go. So the first thing I'll do is go to View XY, just to make sure I'm looking at it correctly. And we're going to go to Geometry, and the circle I want is the first one, the center and diameter. And I'm going to pick maybe 150, 150 as the center. So the diameter is 250, okay, and the center is 150, tab 150, okay. And we're going to just do this quite quickly because there's nothing new here. So we go to Edit, we'll go to Offset, we'll offset a distance of 20mm. I want to offset the line and arc, yeah, that's fine. In fact, I'll offset Geometry, press OK, click the green circle and then click inside it. There we have that. I now want to draw a line. Let's start at the left point of the quadrant. I'm going to turn this on as a construction line actually. So go to construction and then line. It's not snapping on, so turn on the snap to the left. Go from the extreme left point to the extreme right point. Then go again from the top point to the bottom point. And let's go to Edit and Offset. The offset distance will be 5mm, and I want to offset Geometry. So if I click this line and move to the right, this one move to the left, this one move it up, and this one move it down. Now I'm still on construction, so I should have left that as Geometry, but it's very easy to change that in a second. Let's now go to Trim. I'm going to select All and Finish, and then I can trim out all of these pieces that I don't need. Okay, so I'm nearly there now. Okay, so I just have to go to Edit and Change, and I want to change from Construction to Geometry, and I just have these few lines there. And press Finish. So that's the shape that I want to work with. I know there's some construction lines there, but they don't get in the way. Rather than deleting them, if you don't want to see them, get over here to Construction and tick the box beside Construction to hide them. The telltale sign now that something is wrong is that I've got too many ghost tools. So simply go to Edit and Join. I'm going to select All and Finish. And that looks perfect. I should have a ghost tool per piece of geometry. In this case, I've got the outer circle and then 4 of these little quadrants. Now I do want a little curve in the corner there, but I'm not going to waste my time putting on the fillet. When I use the 5mm cutter, the 5mm tool, when it works into the corner, it's going to naturally leave that little fillet, so that's going to work for me. The only thing I have to do first though is go to Edit, and I have to go, sorry, not Edit, Machine, Tool Directions, and I want to go outside. And when I tick this green circle, that ghost tool jumps outside. And then here for inside, I want all 4 of these shapes to be processed on the inside. And press close. And the last thing I need to do is have a piece of timber to cut this from. So let's go to Geometry, Rectangle, and I'll start it at 0, tab 0, enter. And I'll finish it up here at say 300, tab 300, enter. And I'm after doing that as a construction. Let's just quickly go to Edit, Change, and Finish. There we go. At this point, I like moving over to a 3D view. So let's go to View and ISO and 3D, Set Materials, click the square, top 0, bottom -18, and now we have a solid block to machine from. So remembering our process plan, I want to go to Machine and select Tool. We decided that we were going to use the flat 10mm cutter to actually cut the shape of the circle out. So select that and either press Enter or click the mouse. We're going to go to Rough or Finish. It's going to be vertical, I'll leave that be. General, I've nothing to change there. Levels and cuts. Safe rapid level will be something like 40, well above the workpiece. Rapid down to will be about 5mm. Material top we set to 0, and the final depth we go right the way through, -18. Number of cuts, let's do it in 3 passes. Machining data, haven't much to change there. Lead in out, I'm not going to apply lead in or out for this example. Tool data, that all comes in from the tool itself. So press OK, then press the green circle to apply the tooling to that green geometry. Press Finish. Now I'll run the simulation very quickly, and if you remember from earlier, I just have to do this again. Home, select Post, let's just pick the router. And now if I go to View, Solid Simulation, and Play, it does it. Now that's very fast, let's try that again. That's very slow. So there we have it. 3 passes, it cuts the circle. So now to remove these 4 pockets, we're going to go to Machining again, but we're not going to go to Rough or Finish, we're going to go to Pocketing. And it's a vertical pocket, it's got a vertical edge. In the graphic here you can see that red shape is vertical. Let's leave that be. General, it's operation number 1. These are some of the options I'm not going to explore just yet. We're going to explore these in the next exercise, but for now we're just going to leave it at contour, full and inside. And it's always good practice to take account of previous machining, but in this case there's no previous machining that will get in the way. Levels and cuts should load in from the previous exercise. The only thing that's different here is that I don't want to cut all the way down to -18. I only want this to go down, say, halfway, -9. And I'll get that in a single pass. Machining data should be fine, tool data should be fine, so press OK. So I'm going to select this pocket, and this pocket, and that pocket, and that pocket. And press Finish. And you can see what it does if well, first of all, before I launch the solid simulation, you can get a good idea of the shape and the path it's going to follow by looking at these little blue lines. That's where the machining operation is going to happen, and that's the shape that's going to be applied. So one of those options I ignored a minute ago will allow you to change the direction and the shape of this machining, this pocketing, depending on grain direction or the pattern you want to have left. So let's go to simulation again, press play. It'll quickly run through that first operation that cuts out the circle, and you see it starts in the center and machines and mills out all of that material to get this pocket. So all that's left to do now, I'll stop that for a second, is to tidy up the corners, because as it stands we've used a large tool there. In fact, I made a mistake that I'm actually going to fix now. I forgot to change the tool. If I go back to operations, contour pocket, flat 10mm, right click that and select edit. I of course didn't mean to use the 10mm tool, because you can see there's an awful lot of movement there. There's an awful lot of tool paths. I'm going to minimize that. Change tool, let's go flat 20, double click it, and then either press enter or click it there. So now press OK. This is just prompting me that it's about to update it, so I'm going to press OK, and you can see now there's a lot less motion, a lot less work the cutter has to do. I'll just run the simulation again just to show you what I mean. So I'll speed it up. And the problem here is that I don't really want that large radius in the corner. I want to tidy up that. So I'm just going to do a finish pass. This time I'll remember ahead of time to change the tool. So select tool, flat 5mm. See, that'll get into the corner a lot neater. Now we're going to do a pocketing exercise. It's very important here that you take account of previous machining. If you don't tick that, it will start with this tool and try to mill out and machine all that space that's already been machined by the big cutter. So it's ticked anyway, so if it's not ticked, tick it again. So all the other settings should remain true from before. Just press OK and click all 4 pockets again. Finish. There you have it. So if I run the simulation one more time, I won't run it as fast this time. Slow it down. So the red tool, the 20mm tool, is machining and bulking and roughing out all of that material. That's what you want. Use the large cutter for that, and then come along afterwards. As you'll see, when this red operation is over, the smaller cutter is going to come in and just tidy up the pockets. And you see, it's very important to run the simulation, because if you didn't tick that box that would take account of previous machining, that purple cutter now would be moving back and forth there, and it could add 5-10 minutes onto the job just machining out nothing. So just to finish off, let's just explore a couple of other concepts. Now we may have done this already, but I'm just going to make sure we have. If you go to machine and then, let me just find it over here, machine configuration, and then we're going to do open machine. We go open machine, let's just pick 3-axis flatbed router, press open. You can see, because we set it at 0, 0, in this machine, like one of the machines we have in the machine hall, this component, this part here, is the actual 0, 0 part of the machine. So you don't have to work off that corner, you can work off this corner, but you have to know how much to offset this over from the corner is. So there it is, sitting on the component, on the bed rather, of the CNC. So if we run the simulation, it'll actually run there and process it in place as well. This allows you to have multiple different components on the bed of the CNC in different places and machine them at the same time. So I'm actually going to stop that, and I'm going to go to machine configuration, clear machine, and we're back to normal again. Another thing we can do, now this is going to be a good approximation, this is not going to work 100% unless we actually are wired or sitting at the actual machine itself. But if you go to home, you can go output NC code or list NC code. Maybe we'll go to list NC code. Output allows you to save it to a disk or a USB so you can bring it to a machine. List NC code actually shows that NC numeric code on the screen. So if I press this, sometimes you may get this error. It's just about the settings in the machine, and I'm going to ignore it for now, because you often get little errors when the software isn't fully synced up or calibrated to the actual machine you're using. So just press OK for now. And you can see here, operation 1, operation 2. The operation 1 is the finish pass, operation 2 is the contour pocket, and then you can see the total time is 3 minutes 30 seconds. The material is MDF, and what we can do then is go to next page, and this will give you all the coordinates, or I can go next page. There's an awful lot of code there. I just keep going to next page, or list all. In fact, that's better. And there's all the NC code. Now, people who are a little bit more versed in this than I am will be able to write that manually. They don't actually need a piece of software like AlphaCam, but this is the raw data that a machine like the CNC reads and needs in order to process something like this. Now, something else that might be useful. I chose to start by machining out the circle on the outside and then pocket the 4 inside pockets. It might actually have been more stable if I didn't machine all the way through first of all and left as much surface area as possible. The entire square first of all being sucked down by the bed of the CNC while I pocketed that. So if you wanted to reorder that, what you can do is go to Edit, and you can go to First. And what that allows you to do is, let's go Toolpaths. Select first. Okay, well let's say I want this pocket to be first. First toolpath set within operation. So now if I run the simulation, you can see that becomes the first thing that's machined rather than the circle, which was the first thing previously. So you can reorder things. Now there's another way of doing that as well. You can go to operations and you can select this, move up or move down. So here the contour pocket, I can actually select it here and move it up. And now the contour pocket becomes first. That's the way I would actually do it. So you can adjust them. Don't be too worried if you don't necessarily apply the machining in the right order. You can always click them over here and move them up or down as you see fit. Now certain things you can't move up or you can't move down. Like it would not be very smart of me to move up the finish pass to before the time that the rough pass had happened, because that obviously wouldn't make much sense. Now, please save your work and make sure you have it to hand if you ever need it. I'm not going to ask you to upload this week's work because we're not really finished the pocketing exercise yet. So we'll finish off this whole area of pocketing next week. Okay, we'll talk to you then.